Alright, so to finish off the sums and differences of the two areas, we need to find the area enclosed by the following information here. We've got, alright, so y equals x cubed and y equals x take away 2, all squared about the x-axis. Okay, so the axis is the key. Alright, so what you need to set up your variable as. So now, instead of one curve, when we're finding the area between bounds and one curve, we actually find the area between two curves. Okay, so what's the first thing I need to do when I do any area question? Sketch it. Alright, and it's very important you do this style here. Alright, so y equals x cubed looks like what? Okay,
How does it not look like an S?
I keep thinking about that was.
That's a pretty dodgy
We
ass.
do that in any.
It looks like more like an S than anything
It does.
else.
I agree. I was thinking of hyperbole.
That's a cubic.
I'm gonna do that in an exam. It's gonna be horrible. Good.
And y equals x take away 2 all squared. So what is the graph of y equals x squared? Okay, that parabola. So if we are adding a constant within the function,
Doesn't it move it the opposite way?
yeah. Okay, so that's what we covered last term. So if we're subtracting 2 from the original function included in the function, okay, if it was just x squared take away 2, the graph shifts down 2. But if it's an x take away 2 all squared, so incorporated within the function, then you're shifting in the opposite direction. Okay? Or in other words, x take away 2 is all squared is 0, so x take away 2 is 0, so x must equal 2. Alright? So your turning point of course on the axis. There. Alright, so that's the skills that you guys have been previously shown in there so that we can sketch the curve. Okay? Right, so it's asked us to find the area between those two curves and the x-axis. Okay, so in other words, it's asked us to find that area there, isn't it? Okay, so we're bounded by two curves and the axis. Any suggestions on what I'm going to do? Right, there's the curve, blown up. Okay, so we need to find this shaded region there.
Find
Okay,
the intercept.
yeah, good.
Intercepts and then go down from there. You'll find that half and then find that half.
Well, not necessarily half, isn't it?
Oh yeah, but that side and that side.
Okay, so if I just break it up here, like so, alright, for whatever the value for x here, we'll call it a for a moment, until we work out what it is, alright, if I find the area bounded by a and 0 of the cubic, okay, that'll give me the area of this section here, wouldn't it? Okay. Then from that bound to 2, if I find the area underneath the parabola, alright, that will give me that area there, wouldn't it? Okay, so if you break it up, alright, we need to find that intersection point and then find the two separate areas and then add them together. So, how do I find the intersection of 2 points? Of 2 lines, sorry,
X
2 curves.
equals x take away 2.
Alright, so we need to substitute one equation to the other. So they're both y squared, okay? They're both y's, so x cubed is equal to x take away 2, all squared. I wonder if we can answer it in mathematics skills. Find out. Maybe not. Actually, because it's cubic, we haven't learned how to factorise the cubic. In extension, yes.
No. I don't know.
Like prelim extension that we were all.
Oh.
Yeah, but I'm saying the mathematics course.
I got it. Yes, we can. I just said it. I did it.
Well,
Like,
we should be able to do a different.
You factorize, expand,
Yep.
get on one side, and then you factorize the
By
x
grouping in pairs.
squared out. Yeah.
Yep. Right, cool. X cubed equals x squared, take away 4x plus 4. Yep, cool. Right, bring everything to one side. So x cubed, take away x squared plus 4x, take away 4 is 0. And this goes way back to your prelim course, alright, by grouping in pairs. Okay,
The square root of -4.
so I'm going to group those two together.
You can die.
That's what I was thinking of. No, you didn't.
You can settle it though.
Yeah.
That x equals the square root of -4.
Alright, so x squared plus 4, x minus 1 is equal to 0.
Can we just say that that's not a solution?
Hey,
Can we just say it's not a solution? Because
well, one of them
imaginary.
won't be, yeah, for this course, yeah. Okay, so what I've done is I've expanded that side, moved everything over to the left-hand side, then back to your chapter 2 work, factorise by grouping in pairs. Alright, so take the x squared out of these two, I'm left with an x take away 1, and then take out 4, I'm left with x take away 1. So there's your common factor, so I'm factorising that again, and then everything else goes into the other bracket. So that means x squared plus 4 equals 0, and x take away 1 is 0. So just going back over what we previously should know. Alright, so x squared equals -4. Okay, in this course there is no possible solution. Okay, there's no number you can square that equals -4. Let's not go there for the sake of others. Right, and then x equals 1. That's our only solution. And that makes sense because there's only one intercept point of your parabola and cubic. Okay, so that means the halfway point is 1. So it is halfway. So that point is halfway, which is 1. Won't always work the case. Alright, so the area is going to be equal to the integral from the highest to the lowest bound. So I'm going to do the left-hand side because I'm going to find the area underneath the cubic from 1 to 0. And we're integrating with respect to x. Okay, so we're integrating with respect to the x-axis. We need y equals, or our function of x, so that we can integrate. Okay, same thing, just two ways to word it. And then we need to add the area under the parabola. So we've got the bound at 2 and 1 of x take away 2, or squared dx. Right, so we need to find those two separate portions and then add them together. Okay, what's the integral of x cubed? Okay, add 1 to the power, divide by new power. Okay, you can factorise the quarter out, but really there's no point because I can observe that there's 0. Alright, and I'm all going to write as a quarter for that portion. Plus, now what's the integral of x take away 2, or squared?
X cubed over 3 take away 4x to the power of 2 over 2 plus 4x plus c.
Don't need constant expression because it's definitely integral. Now, what been done is this has been expanded from our previous work, and we've integrated by doing that. However, I have taught you how to do the function of function. Okay, so x take away 2, add 1 to the power, divide by new power, then multiply by the derivative inside the bracket. Alright. So there's two different techniques. You can either expand this, as we've already done here, integrate each part. Right, I'm just going to keep it like this to remember how to integrate with function of function. Right, so it's going to be a quarter, take away 0, plus. Right, so I've got 2, take away 2, which is going to be 0, make everything else going to go to 0. Minus a negative 1 cubed over 3. Okay, so that's why we need to have bracket and make the correct substitution so that we have the correct area. Alright, quarter plus a third. Right, add those two fractions together and get 7 over 12. Unit squared is just over half a unit. Okay, so that's why diagrams are useful. So you can see what you're doing, you can see how you need to break it up or how you need to manipulate the questions so that you can answer the question. Right, any questions on that process?
There's not much to it, is there?
Hey,
It's not that hard, is it?
not meant to be. You've got to obviously understand what's going on before you can do the work. Okay, there's no point knowing how to integrate but not being able to know what to do so that you can integrate. Okay, is there anyone here that did not follow that process? Alright, let's try another one. Make sure you understand. Okay, find the area enclosed by the curve y equals x squared and the line y equals 2x plus 3. So we need to find that area bounded by those two curves. Well, one curve, really a line, still a type of curve. Just like a square is a type of rectangle. It's a very neat rectangle. Okay, step number 1 is to sketch it. Alright, so that you are aware what the question is asking you to do. Right, so we all should know that the parabola is the graph of a quadratic. We all should know that a across b is a straight line. Okay, so you've got the y-intercept at 3 and a gradient of 2. So from the y-intercept at 3, got to go up 2 and then across 1. Okay, up 2 across 1. And then once you do that, or otherwise, table values, etc. Okay, we are needing to find that whole shaded area. Okay, so there is no axis referenced here. Okay, because you're asked to find the area between two curves. So what do I need to consider first before I can start integrating? Yep, okay, so we need to know where the areas are bound. Okay, so you need to set up the simultaneous equation. And on my graph there are two intersection points. Okay, so by the solving of the quadratic there, I should have two solutions. Right, so they're both y equals, so x squared is equal to 2x plus 3. So we're finding the intersection points so that we can calculate, we've got the bounds so that we can integrate. So x squared, take away 2x, take away 3 is 0. So two numbers multiplied together to give -3, same two numbers add to give -2.
Negative 2. No.
Negative 3 and 1.
So x take away 3, x plus 1 is 0, therefore x equals 3 and x equals -1. So that makes sense in terms of the question.
Yeah.
Sensible answers? What if they're both negative, for example? What if I said x equals -3 and x equals -1? Would that be an appropriate answer? Okay, so you need to use that sort of skill, quick checks, as you're going through the question. Okay, nothing worse than getting to the very end of a question after you've done a bit of work and realise you made an error towards the start. Okay, and I've done that, been there. I'm sure you've all had that experience as well. So make sure that. Now we only need the x value. Okay, because we are integrating. I'm going to treat it like the x-axis in there. So I found my bounds. What's the next thing I need to do or think about?
Find the area underneath the line.
Yep.
Find the area underneath the curve.
And? Excellent. Right. So, what was said then, if I find the area underneath the line, okay, so I'm just going to rub this out for you. If I find the area underneath the line, okay, ignoring the parabola for a moment, I'm going to have this whole shaded region there. If I integrate just the area underneath that line and the x-axis. Okay. If I then integrate underneath the parabola, right, I'll find that area. So if I take away the area underneath the parabola from the area underneath the line, I'm going to remove this portion here because I'm taking away the area that I've already calculated for the first curve. Okay, so really what I'm doing, okay, so between those two bound, I'm finding that whole region there underneath the line. Then, oh, that's probably drawn. I'm finding that region underneath the parabola. And if I take this area away from that area, okay, I'm going to get the area between the two curves. Okay, so that's what you need to think about. So, in other words, if I calculate that area, what I need to do is find the area of the highest curve, take away the area of the lowest curve. Okay, so area is the integral of the highest, take away the integral of the lowest. Observing the fact as well that I've got all my area above the x-axis, so I don't need to consider changing the limits of integration. Okay, if it was with respect to the y-axis, I'll need to break it up because we've got both positive and negative area. But I'm taking it all with the x-axis and everything's above. Okay, so the highest is the line and the lowest is the parabola. So the integral from our bounds that we just got there, so 3 to -1 of 2x plus 3 dx, take away the area of the lower. So below the line is the parabola. Okay, so everyone following up to that point?
Mm-hmm.
Yep. Right, so because they're the same and bounds of integration, right, I don't have to integrate twice, I can just include that part of this one. Connor. Right, now there's only one part to this function, but if there's more than one, I just have to be careful with the sign. So that's why I'll put a bracket there. Right, but because they're bounded by the same point, I can just all include it into the one integration rather than two separate things and have to do 4 calculation. Okay, the integral of 2x squared, integral of 3x, and integral of x squared. Add 1 to the power, divide by new power. Okay, from 3 to negative 1. Alright, so it's going to be 3 squared plus 3 lots of 3. Take away 3 cubed over 3. So you're substituting 3 every time there's an x there. And then you need to take away the primitive function at the lower bound. And don't forget, when you take away, you need to include your bracket because you're taking away more than one component of a term. And what's your negative numbers and your substitution? Okay. You have to put these brackets and you've got to be very careful about how you put these things in the calculator. Alright, so 9 plus 9, take away 9. Okay, so you either go into the calculator at this point, being careful with how you're substituting your negative numbers in, or you can use your math skills and tidy it up a bit before you have to go to calculator. So negative 2 plus the third, so negative 6 over 3. Okay, so you've got to watch your sign. So that sign came from this one, and the resulting inside that bracket is negative 5 over 3. So you have to be careful with your substitution. 27 plus 5, 32 over 3. And that doesn't simplify down. Okay, and because we've found area, we need to include the units as well. Right, question?